Hello, I'm Patty Simpson with Simpson Math. Let's talk about some vocabulary surrounding hypothesis testing. First of all, a hypothesis test is just a technique for testing a claim about a population parameter using statistical principles. So we're going to look at some parameter, some value from the population, and we're going to test that using some different statistical principles. Then an alternative hypothesis, denoted with a capital H and a subscript A, is a mathematical statement about the parameter and its hypothesis that the researcher is trying to gather evidence in favor of. It's also called the research hypothesis. So this is the hypothesis that the researcher has that they are testing. Then the null hypothesis, or this is a capital H with a subscript 0 there, is the mathematical opposite of the alternative hypothesis. It will always include the equality. And we practiced finding some alternative and null hypothesis earlier. Then a test statistic is the value used to make a decision about the null hypothesis and the statistics derived from the sample. So let me explain a minute. So we have some parameter out there that we think is true. But the researcher decides, hey, I have some hypothesis that maybe that statistic is too high, or that parameter is too high, or too low, or it's just not equal to that. Then what we're going to do is we're going to test that parameter. And in order to do that, we're going to go out and collect a sample that's at least 30, and it's a nice random, simple random sample, so that we know that that test statistic, that statistic from that sample, fits into that sampling distribution that has that normal shape to it. And then that is the test statistic. The statistic we get from our sample, we're going to use that statistic to test our hypothesis. And so therefore it's called the test statistic. Then that test statistic is said to be statistically significant if it is far enough away from the presumed value of the population parameter to conclude that it would be unlikely for the sample statistic to occur by chance if the null hypothesis were true. Remember that we're going to assume that the null hypothesis is true. It's just like in a court of law, you assume that the person there is not guilty until you see enough evidence to convince you otherwise. It's the same thing with our null hypothesis. We're going to assume it's true until we get a test statistic that's so far away from our parameter that we're like, there's something weird there, that it is statistically significant. Let me draw you a picture and kind of show you what's happening here. So when we collect a statistic, a mean or a proportion from a sample, and it's part of that sampling distribution, we know then that that sampling distribution has that normal shape to it. So our mean is there in the middle, and we expect our sampling distribution to have the same mean as the population. So we created confidence intervals to say, well, when we collect that sample, the mean may not be right there. It might be a little bit to the left or to the right of that, but we know that because it's in a normal distribution, 68% of the time it's going to fall within one standard deviation. 95% of the time it's within 2 standard deviations, and 99.7% of the time it's within 3 standard deviations. So we expect it to maybe be a little bit bigger or a little bit smaller, but we expect it to be within 3 standard deviations for sure from the mean. If it's further out than that, then we go, there's something really weird happening. And we can adjust our confidence level. So maybe I'm only looking at the 68%. Well, then if it's further out than that, then I say, well, that is statistically significant for me. That's enough evidence for me to see that that mean is, for me to reject the null. We'll talk about that a little bit later. 95% is usually what we use. So if it's at least, out there to that 95%, If it's further out on either end, then I start going, maybe that's big enough for me to say it's statistically significant. It's far enough out there that it would be unlikely for me to get that statistic. Or, out 3 standard deviations, maybe I'm using that as my confidence level. Which, by the way, the level of significance, which we use this alpha to denote that, is the probability of making an error of rejecting a true null. Remember that when we talked about our confidence intervals, that our confidence level we denoted as C? Well, with our level of significance, we're going to use alpha, and it's just 1 minus C, or you can think of it as the complement of C. So if my confidence level is 95% or 0.95, then my level of significance would be 0.05. It would be 1 minus that 95. And that is your level of significance. So that statistical significance depends upon your level of significance. How far out is it? If my level of significance is, 0.3 or 0.15, I would need to be way out there. But if my level of significance is like 0.1, 10%, then it would be closer to the mean. So my level of significance tells me how far out that is for it to be far enough away for the probability for that probability to be, ooh, that's weird. There's something weird going on. So the level of significance we'll look at when we're doing a hypothesis test, and that'll help us determine whether or not it's statistically significant. Let's look now to see what are the conclusions that we can come to from a hypothesis test. Math Made Simple is some math. Thanks for watching.